Good morning, viewers, and welcome to my channel. Today, we are still going to continue with our chemistry, our core chemistry. We are going to continue with concentration of a solution. Concentration of a solution. Now, before we can talk about concentration, we have to look at solution because concentration is embedded in the solution. Yes. So we talk about a solution and we say that a solution is a uniform mixture of two substances. And these two substances is a solute and a solvent. So a typical example is a salt solution. So if you want to form a salt solution, you put the salt into the water. The salt is the solute and the solvent is the water. Yes. Now we talk about solution to be a uniform mixture. It's uniform because this solute dissolves completely in this solvent. That is why when you place salt in water, in no time you will see after some time you won't see the salt again. It mixes completely. The same is true for sugar. Yes, so that is a solution. Now that we know solution, let's look at a concentration. So concentration is the measure of how much a given substance is mixed with another substance. How much a given substance is mixed with another substance. Yes. So considering the salt solution that we talked about, say that the solute, the salt, when it is more than the solvent, we have a concentrated solution. Yes. So sometimes this is very rare. This is very real in your various houses when you are preparing soup and the the the, the salt is too much, realize that the soup becomes salty. Yes. So that is tells how much of salt was placed in it. So it means that the salt is more than the water given and it makes it concentrated. Yes. So that is concentration. Yes. Now, the concentration of a solution can be expressed in these following ways. The first one is amount of substance by volume of solute in a solution. And looking at the amount of substance by volume of solution, we have the unit mole per dm cube or mole per liter. That means that amount of substance which we all know to be in moles and our volume this time around our volume is in decimeter cube or liter. So that means that when you want to find the concentration, you are given the amount of substance and the volume, then it means that you have to get the unit mole per decimeter cube. We can also find concentration by mass by volume of solute in a solution. Yes, so when you are given the mass and the volume too, you can find the concentration, and that will be in gram per decimeter cube. And the third one, you have mass by mass percentage of solute in solution. And that one, since it is mass by mass, the the unit of mass, which is gram and gram, will cancel. So there is the need for us to leave it in percentage. So that is another way to you can calculate our concentration. Yes. Now we are going to consider the first one. In this video, we are only going to consider the first one, which is amount of substance by volume of solute in a solution. That is mole per decimeter cube or mole per liter. Yes. So in the subsequent videos, I'll talk about mass by volume of solute in a solution, then mass by mass percentage of solution. Yes. So we are going to consider the first one, which is amount of substance by volume of solute in solution. Yes. So concentration of a solution is expressed as amount of substance in moles per volume, which is in decimeter cube or liter of solution. So this is the formula. So our concentration is equal to amount of substance n, small n, over our volume of solution, which is small v. So we know the amount of substance is in moles, so number of moles, which is still n, the volume of solution, which is v. So the unit of amount of substance is small m, small o, small l, which is our mole, and our volume is in decimeter cube. So this is the unit for concentration when you have an amount of substance and the volume. So you can write it this way or can write it this way and you understand. Yes. So if you are given the volume in centimeter cube, this conversion is going to help you so that you can find the volume in decimeter cube and continue with your work. Realize that 1 decimeter cube is equal to 1000 centimeter cube, and 1 liter too is the same as 1000 centimeter cube. So, you know, if you are given in decimeter cube and you convert, it's the same, it represent that of liter. So in place of decimeter cube, you can still put liter there. Now, let's take an example and solve. So our example 1, what is the concentration in moles of sodium hydroxide per decimeter cube of solution containing 60 grams of sodium hydroxide in 1 liter of solution? You are taking atomic masses to be 1 for hydrogen, 16 for oxygen, and 23 for sodium. So all that the question is asking us to do is we should find the concentration. You see, the concentration in moles of sodium hydroxide per decimeter cube. So they want us to find the concentration in mole per decimeter cube. So you see this unit, mole per decimeter cube. Yes. So that means that you have to find the amount of substance. You have to find the volume. So let's see what we were given. So as we are finding concentration in mole per decimeter cube. Now we must know the amount of substance, and it wasn't given, but we were given the volume to be 1 liter. So this is the volume, 1 liter. But you were not given the amount of substance, but you were given the mass of this, and then the atomic masses too were given. So that is going to help us to calculate the amount of substance. So you need to find the amount of substance first. And from the previous video, amount of substance is given by mass over molar mass. Mass over molar mass. And the mass was given. The mass was given. This is the mass, 60 gram. 60 gram it was given. Yes. So it is up to us to find the molar mass. And you know how to find the molar mass for sodium hydroxide. Yes. Since sodium is 1, oxygen is 1, hydrogen is 1. Just multiply 1 by 23, you get 23. Multiply 1 by 16, get 16. Multiply 1 by 1, get 1. So when you add, you get 40 gram per mole for molar mass. We come and substitute it here. We know our mass already to be 60 gram from the question. Then our molar mass, which we have calculated it to be 40 gram per mole. When you cancel the grams and the grams, you'll be left with mole. And divide 60 by 40, you get 1.5 mole. So that is the amount of substance. Now that we have the amount of substance, we can go back to concentration. We want to find concentration, but we didn't know the amount of substance, so we only calculated for amount of substance here using the mass and the molar mass. So we are going back to what we have to find, which is our concentration. So now that we know amount of substance to be 1.5 mole, we put it there. So if we come down here, we have the amount of substance to be 1.5 mole, and our volume, which was given initially in the question to be 1 liter, is here. So sodium hydroxide in 1 liter. So that's the volume. So we go back, substitute. So our 1.5 mole over our 1 liter. Then when you divide, you're going to get 1.5 mole per liter. But initially, the question said that we should find concentration in moles of sodium hydroxide per decimeter cube. So it is asking us to leave it in mole per decimeter cube. So we can also write concentration to be 1.5 mole per liter or 1.5 mole per decimeter cube. Since liter is same as decimeter cube, you can just substitute. So we have found for the concentration in mole per decimeter cube. Let's try our last example. So our second example, a student dissolves 5.8 grams of sodium chloride, this is the formula, in enough water to make 250 centimeter cube of solution. Calculate the concentration of the solution in mole per decimeter cube. So you have to calculate the concentration in mole per decimeter cube, but the volume was given in 250 cm cube. So that means that there will be a conversion here, because we need to get our volume, which is in centimeter cube, in decimeter cube, because this is how we should leave our answer. So this is what you are going to do. Now we need to find the molar mass of this sodium chloride. So in calculating molar mass, we say that since sodium is 1 and chlorine 2 is 1, we use the atomic masses. Atomic mass for sodium is 23. 23 times 1 is 23. Plus that of chlorine is 35. And 35 times 1, since they are 1, 1. 35 times 1 is 35. We add it, we get 58.5 gram per mole. 58.5 gram per mole. Now we have to find our moles because the moles wasn't given. The moles wasn't given. So we have to find our moles, our amount of substance. That's the same as the moles we are finding. Yes. So amount of substance which we calculated just before this question. We calculated amount of substance. Then we said it is mass over molar mass. Our mass was given 5.8 grams. It is here. So we substitute there. Then our molar mass, which is 58.8 gram per mole, is here. This when we calculated, we had this. So 58.8 gram per mole. When you punch, the gram will cancel as usual. So when you punch, you get 0.09915 mole. Now we have the mole. We have the amount of substance. But concentration is amount of substance or the moles over the volume. So we know the amount of substance or the moles. But do we know the volume? Yes, we know the volume, but it's in centimeter cube. But the question is asking us to leave it in mole per dm cube. So what we are going to do is that use our special conversion. So 1 decimeter cube is equal to 1000 centimeter cube. So 250 centimeter cube. We expect less. So if you expect less, then the bigger one will come down. So we are going to get 250 centimeter cube divided by 1000 centimeter cube times 1 dm cube. So 250 centimeter cube divided by 1000 centimeter cube times 1 decimeter cube. And centimeter will cancel centimeter. Then you divide 250 by 1000, then you get 0.250 dm cube. So our centimeter cube is now in decimeter cube. So you substitute it here. So our amount of substance is mole, which was calculated to be 0.09915 mole is here. Then our volume in dm cube, which we converted from here to, is 0.250 decimeter cube. Then when you punch, you get 0.3966 mole per dm cube, and that's the concentration in mole per decimeter cube. You can leave this one. You can leave this one. But you can just round this one so that you get 0.40 mole per decimeter cube. So this is how concentration is calculated in mole per decimeter cube. So thanks for watching and stay tuned to more updates and more videos. Yes, please don't forget to like and subscribe to my channel.